Okay, in this presentation we are going to look at continuous random variables, okay? So in this instance, both x and y are two continuous random variables, and what we're asked to do is demonstrate this identity here, okay? So it uses all the building blocks for the theory for this type of stuff on a course. For example, the conditional expectation, the joint density function, the marginal density function, conditional density, all that sort of stuff. Okay? Now there's a lot going on here. I'm going to try and keep this video short, but just to sort of spot all the things and how they interlock with each other. Now, to start off with, there is a definition here about... Sorry, let's actually look at this here to start off with. We have the expectation of x, the expected value of x, and we're saying that that is an integral of the conditional expectation of x, conditional on y, times the marginal density function of y, and we integrate that, okay, dy, okay, with respect to y. So it's essentially, we have three sort of components there to start off with, and what we're going to do is sort of show that the expectation of the product of those two terms there. Okay, so let's actually just start off with the conditional expectation. Now, actually, there's two cases here. Okay, so there's a case here where x is continuous and y remains discrete. We're not interested in that. There's a second case down here where both are continuous, and in this instance, that is what we need to work with, this one here. Okay, so essentially the conditional expectation, which is this term here, can be expressed as the integral of x times the conditional density, okay, the integral of those two terms, dx, okay? Now, the conditional density, furthermore, can be expressed as the joint density function divided by the marginal density function of y. So it's x given y, so down here we have the marginal density of y. So that's an important place to start off with. There's a second thing we actually have to just sort of remember is marginal density functions, okay? Now, you might notice there that I'm actually shortening the names a bit. It's just for the sake of brevity. So this stuff needs a bit of a read through as well, just so you're clear on all of the notation and stuff like that. Again, just recall that I'm being brief as much as I can here. Now, essentially, the key thing here is actually expressing the marginal probability density function here and expressing it as an integral of the joint density function here. Sorry, my page slipped there. Okay, so here we have the joint density function in both cases. It's both. You can disregard the limits in this one. This is a sort of general definition here. So for the marginal density of y is the integral of the joint density with respect to y. Sorry, for x it's with respect to y, and for y the integral is with respect to x. Okay, that's just the sort of thing to remember. Use the opposite variable when you're doing these integrations. Okay, now so let's start off here. Now, I realize it's a little bit clunky, but we'll start off here with a general definition of the expectation. Okay, that's our sort of starting point. What we're asked to do is express that as the integral of the conditional times the joint density function. Hang on a second down here. I got it. So, how do we start off here? Well, we'll start off here with the marginal. Okay. And what we're going to do there is express that as an integral. The integral of the joint density function dy. Okay? So that's just a sort of how to start off on this. Now what I'm going to do here is just rearrange this. So I have x out here. Just bring it in here. I have the joint density function there. I have dx and dy. Just put them there. Okay? And we put the integrals out here. So you have a double integral out here, okay? Oops. So here we are now. This is where we're at right now. So what I'm going to do now is go back here to the conditional expectation. I mean, in particular, this part here. This part here. So what I'm going to do is just rearrange that mathematically. So what I'm starting off with is, or I'm going to use that there. So I have the joint density function of y. So what I'm going to do here is that in terms of the conditional density times the marginal density of y. So that's how I come to this. Okay, just re-express that fraction. Okay. Now, I'm going to reorder things now. So I have x times the conditional density here. Okay, so I'm going to bundle them up and express them as an integral. Okay, use one of these integral signs here, essentially, and dx. Okay, and then whatever's left is the integral of the marginal density of y dy. Okay, and using our definition of the expectation, the conditional expectation, which is, let's go back here, this one here. Okay, so there we go. So that's it done there. It's tricky, this stuff, okay? So you have to be very clear about all of the definitions. Conditional density, marginal density, joint density, conditional expectation. They all play a part in these sort of questions now. So when you start off with a question like this, it looks very small, very quick, but actually there's more to it than that, okay? So I'm just inserting a quick edit. I just realized I made a mistake here at the end. So this expression here should continue on here, okay? So that's wrong. So I'll just rewrite out this line here. The integral of the expectation of x, the conditional on y, times the marginal of density of y. Okay, so that's just a little typo there, so you can ignore that. So essentially, you know, we're up to speed all the same, so that's just a typo. So that's actually what we needed. Let's just check that. Yeah, that's where we needed to be. So overall, it was using stuff like conditional expectations, conditional densities, and so on. Marginal densities, joint densities, and so on. That's how we tackle this question. Okay, we'll leave it there.